Big round of applause for Technical Solution Specialist at Neogen, Arlene Larson, Technical Solution Specialist Manager for the US and Canada, also at Neogen, Miss Anna Lozano.
Thank you, Frank. Okay, so hello everyone. Good morning. I'm going to grab some water here first. How's everyone doing? Good? This is not an interesting topic, Frank.
I felt like you led that. You were going to do a comedy sketch, but
I know. It's, but it's a must. We got to talk about that. But anyways. Okay, so I am a little bit, I'm short. So I'm going to be fine. Thanks God I have my notes here because my size doesn't allow me to read the notes on the back. Well, hello, everyone. We are going to talk about something that unfortunately we have to keep talking about. It's Listeria. We have 3 parts on our presentation. So the first part is why Listeria still matters. Then I'm going to point here. Then we're going to cover environmental Listeria programs, some core concepts and best practices, and then I will pass it over to Arlene, who is going to show you how to go from a positive to mapping to control. That's the workflow that we suggest. And it's going to be an interesting presentation, a little bit more kind of hands-on things that you can bring to your facilities. So hopefully you can get good stuff from this presentation. So very quickly, I am Anna Lozano. I am the Technical Solution Manager for US and Canada at Neogen. I have been working in the food industry for about 20 plus years. 15 years in the industry before joining 3M, now Neogen, as a technical representative. So I have some experience. And joining me today is Arlene. I'm going to let you introduce yourself, Arlene.
so similarly to Anna, I do have a long history supporting the food industry. I did get my start in molecular biology, and I've done some graduate work in food science as well. My start in food safety was in 2008 at Maple Leaf at their corporate lab, as I think many of us have done our time at Maple Leaf at some point in our career. But after that, I've held various roles supporting food safety, whether it be through third-party testing or in a field like biotech, like I am in today, as a technical solution specialist with Neogen. So that's it.
Thank you. So yeah, between both of us, we have more than 40 years of experience, and we try to bring that to our customers and give you the best support that we can. Okay, with more, let's start. And I will start covering this first part. Well, before we talk about responses and best practices, I really want to take a step back and remind us why this topic continues to deserve a lot of attention, unfortunately. Especially in ready-to-eat environments. And, well, first of all, these 2 first parts of this session are based on a Listeria control webinar series that we presented with experts like Dr. Byron Chavez, Dr. Rolando Gonzalez, Angie Simmons, and Gretchen Walls. And it was designed to guide manufacturers to the latest regulatory updates and practical responses that you can actually take to your plant. Root cause analysis and prevention controls is available online. It's free. It's a series of 4 webinars. So these first 2 parts are actually a summary of those webinars. The third part is it's the part that is going to cover Arlene. It was born from what we got from those webinars. We also use our new environmental monitoring handbook, the 2nd edition that was launched last year. The first edition was great. The second edition is amazing. So strongly recommend you to go over that. It's a free guideline as well for environmental testing for food manufacturers. You can download it for free as well. We have some physical copies. Arlene is going to share with you a link that you can use to download that handbook later. Okay. Why Listeria still matters. So unfortunately, Listeria remains a major concern because it has not gone away. We're still experiencing a lot of Listeria recalls and a lot of events. And especially for those ready-to-eat environments that are more vulnerable to post-process, post-kill contamination. So it's still there. The main concern is not necessarily the introduction, but the persistence per se. Even when product is produced under good process controls, the non-process controls are not necessarily taking care of the environment. And that's why environmental monitoring is just not like a routine activity. It actually is critical for product protection because that's where we have all the harborage sites and continue to drive risk to the product. And regulatory agency continues to emphasize that environmental monitoring and verification are crucial because that's where the risk remains, not necessarily under process control. We have control on those steps, but the non-process controls are where we are neglecting. And speaking of regulatory, one important driver or one important reason to why this still matters is regulatory expectations. So the regulatory language might differ, between agencies, but the expectation is very similar across all of them. The Canadian Food Inspection Agency, the FSIS, FDA, they all expect very similar things. And they really want us to have an effective environmental control, and that goes beyond just sampling. We are used to, okay, I have to do environmental testing, I test and that's it. No, we have to go beyond that. The expectation includes that we can detect the risk, so we are able to know that is and where it is, investigate the findings. It's not just finding, cleaning, negative, okay, I'm good. No. We have to document the actions and show ongoing control. All of them, they mention that. So this is especially clear for ready-to-eat and especially clear here in Canada. Okay, so now moving into part 2, I want to focus on the core concepts and best practices that were shared during these webinars. This is where we go on from why it matters to actually actionable good practices that differentiate strong environmental monitoring programs to those that are just built to just check the box. And let's start with one of the biggest myths in environmental monitoring. The idea that positive Listeria findings are automatically a failure. In reality, a positive can mean that the program is actually working well. And that's what Dr. Chavez says. You found a positive? Congratulations, your program is working. Because it's showing that there is a lack in the system and is capable to detect the contamination before it gets to the product. So that's what a positive shows. What really matters is not the illusion of zero findings. I have seen customers very proud that they have zero Listeria in their plant. You're maybe not looking enough. That's not what matters. What matters is how you respond to those positives, how quickly we assess the risk. I know where it is, and I need to assess the risk around that and for my product. And how you investigate the sources, and how you put actions in plan to mitigate that risk. So, a positive is actually a sign. It's not the end point. Is assigned. And the real goal here is to understand the source. So environmental monitoring and the positives are strong just if you focus on control strategies. In source, in niches, and those transfer routes, you have to let the environmental monitoring talk to you and show you why you have that positive. See all the data that you have. We have talked a lot about AI during these sessions. Well, you have to gather good quality data, and AI is a fantastic tool to help you analyze the data that you're gathering from ATP, from indicators, from pathogens, not only one, everything. They are not isolated programs. So we can evaluate from environmental monitoring from positives, not only the verification, what is happening with our verification process, but also, we cover this in chapter 2 of our environmental monitoring program, also validation. You can use environmental monitoring data to revalidate. Maybe that is showing you that that machine that maintenance and production are telling you that is good, and you can keep working with that machine. Maybe you have the data to show them that you have to re-clean that and revalidate the cleaning and sanitation, and now you have to disassemble that machine, not in a monthly basis, but in a weekly basis, so it's very costly for the company, and they might change the machine. So that's just some of the things that you can do with this data. So it's actionable data that you should use. And this slide help us think more operational way. It's about where the risk lives and how it moves. How it moves, guys. We need to understand how our bugs move in our plant. Except if you work in pharmaceutical, it's natural to have bugs. I see environmental monitoring, and I make the analogy with the blood test for sugar. It's natural that we have sugar. It's just that we need to know our limits, and we need to know how it moves and what are the max. We need to understand the environment. So that is the real value of environmental testing results. It helps us prioritize actions where there is more exposure. So Arlene is going to present as an example. We generated this image, but you see a crack here, and we see the traffic. And we also need to think about the vectors, very, very important. Vectors that will transfer the contamination to risk areas. So water, traffic tools, equipment, and employee movement can all move contamination from one area that is not risky to an area that is risky. So positive research should never be viewed in isolation, said Dr. Chavez, from the surrounding environment and the process flow. They are one. Another important takeaway from the webinar was around immediate response to positive. And here, well, as I mentioned before, we have the setup that we have to re-clean, retest, and the negative. And we're good. We can show that to our regulatory entities and our auditors. Well, no, it's not enough. That's not the goal. That's not how we should respond. We should start, of course, with an immediate control containment and understand if the exposure, and this is what Dr. Simmons said, how if my product was exposed, what was exposed. According to Dr. Simmons, the first step is immediate containment and exposure assessment, always tied to zone, location, and process context as well. So very important that. We need to find the real cause and solve the problem from the source. And just re-clean, retest, and having a negative, that is not a root cause analysis. From there, root cause analysis becomes essential. Gretchen Walls, on the third webinar, she really frames this really well. She says that root cause analysis is about the why, not just the what. Root cause analysis should explain why the hazard was introduced, why it survived, and or how it spread. And the goal is to understand contributing factors. She actually makes an analogy during the webinar around escape room and how you have to find the clues on escape room. She invited us to approach environmental control for Listeria in the same way. to find the clues with ATP, with indicators, with index testing. We're going to hear more about that, but that's what she suggests. This is why practical tools like 5 Whys and the fishbone come extremely helpful. Chapter 9 of our Environmental Monitoring Handbook, the 2nd edition, explores more on how you can use those tools. And the other piece that she covered was about cross-functional team with authority to act. Root cause analysis needs the right people. We cannot do it ourselves. We need maintenance team, we need production team, but team that can actually act. Because if we make decisions as the root cause analysis team and we cannot actually implement that in plant, we're doing nothing. Well, and with this, I'm going to pass it over to Arlene. Otherwise, we're not going to have time for questions. I'm going to see it here.
Thank you.
Thank you.
Okay, so up to this point, Anna has taken us through mindset, risk, and response. She's talked about what a positive means and how we're going to investigate it. So now we're going to shift from that understanding portion to an application. So you'll hear a lot of the same words that Anna's used, but I'm going to try to apply it to a scenario. I'll provide you with that framework on how to investigate the findings and use a structured approach in how you approach your actionable data. So it's all going to start with that positive being detected in your environment. This is going to be our trigger for additional actions. From here, we're going to move into vector sampling and investigative swabbing. Your root cause analysis team is going to explore beyond that original site and look at the surrounding areas. We want to establish where contamination might be present and how it's migrating through the facility. Then we're going to map those results that we've gathered. This is what is the turning point that Gretchen had mentioned. Turning point is where we take our mapping results and we can actually use that for further action. It's going to allow the root cause analysis teams to visualize the patterns that are within the facility, and these patterns are going to be far easier to see when you visualize them on a map as opposed to just looking at data. From there, this is something kind of new that Gretchen talked about. It was quantification. With quantification, what we're going to be able to see are the concentrations of where those Listeria species lie at those specific sites. The quantities where highest could potentially be those hotspots or the original niche or source of contamination for the facility. So at this point, your team is not only going to act at that original positive site where it was detected, but at that source that they've identified, which is possibly going to eliminate that source of contamination for the facility and prevent reoccurrence. So how does index quantification turn a positive into direction? Well, it helps us answer a couple of questions. I've already mentioned this before. We're going to be able to determine where our concentrations are highest. We're going to see how the spread is occurring, and it's going to allow our root cause analysis teams to act first where it's more important. Quantitative testing will also help us establish baselines, cutoffs, and it's going to allow us to visualize the trends that are going on. Are things improving with our actions? Are they stabilized? Or even worse, are they getting worse? Sorry, there's a bit of delay. So index quantification in combination with that mapping is going to allow us to have spatial analysis across the facility. It's going to help us establish where those true hotspots are versus isolated events. Each data point is now going to be far more valuable because not only do we know where it's located, but we also have the concentration and we know its proximity to our products and risk areas. This is where the patterns really start to stand out. So we might see that we have a small cluster in a corner, and what that's going to indicate is that we have a potential harborage site. Or we can actually see the quantities throughout the facility, and we can determine, okay, this is how the Listeria is migrating through the facility. It's usually going to come from, of course we know this, we would have to look at how our employees are moving, how water is being distributed, and the other thing I always forget, equipment. Equipment moves product as well. Unfortunately, at this point in time, there's not a one tool that's going to fix it all. We do have to rely on an integrated workflow for environmental Listeria control. So at the start, where we found that first positive hit, this is always going to be done using a validated test method to determine that Listeria species. From there, it's going to trigger further actions. So of course, if we do have that positive hit, we're going to have to investigate. And for our investigation, we're going to use quantification and mapping to understand that extent of contamination, determine potential harborage sites or source areas, and look at the routes of migration throughout the facility. Next, we're going to mitigate. Immediate interventions can be taken to control or reduce our risks here. So here, having a faster environmental insight is going to be highly valuable as it's going to support very timely actions. And finally, we verify. This is where we're going to revert back to our routine monitoring, and this is going to include our hygiene monitoring, indicator testing, and then, of course, our environmental Listeria program. We're going to resume regular data review, we're going to observe trends, and we're going to confirm that we have control over the situation. So we all know that the reality of any food production facility is that not all risks are going to be immediately eliminated once they've been identified. So in the example here, Anna had referenced this before as well, we have a crack that's developing on the floor. And the danger here is that it's immediately adjacent to a zone 2, and at some point, even a zone 1. We know that the crack means it's going to retain moisture, it's possibly going to capture food debris or organic materials. It's going to be an optimal harborage site and potentially a contamination route for that particular line. Addressing this issue, whether it's going to be through repair or design, may require downtime for the facility, planning, or even capital investment. The question here is going to be, how are we going to manage this risk in the interim? Well, there's a couple of things that we can do, and probably we're going to be using all of these in combination. We can enhance our cleaning and sanitation frequencies. We can restrict traffic or modify workflows around that area. We can increase targeted monitoring for that specific region as well. Here again, having that rapid environmental insight is going to be a huge advantage because it's going to allow us to quickly assess the contamination and evaluate the risk to nearby areas. What I've listed is not going to be any replacement or permanent corrective actions. These are just interim mitigation steps that can reduce exposure while the root cause is being addressed. So just some final notes with regards to Listeria control. Positives should be expected, as Anna mentioned. Systems need to be prepared and respond effectively when they do occur. Positives are a trigger that are going to initiate some next steps for you. It's going to include structured investigation, mapping, and a data-driven understanding of what the issue is. Strong programs should also focus on identifying those sources and the transfer routes, applying targeted risk-based corrective actions, and use mapping and quantification to see patterns and hotspots in the facility. I had mentioned an integrated workflow. It's important to connect that detection, investigation, mitigation, and verification into a continuous cycle. Even when risks cannot be immediately eliminated, strong programs are going to demonstrate that they have control through proactive science-based decision-making. And this is just a callback to something that Gretchen had actually alluded to in her presentations. That was number 3 of the webinar series. The best programs are defined not by the absence of Listeria positives, but by the quality of their response and the ability to continuously learn and improve. So Anna did mention that webinar series, and she did have that QR code. This is a QR code to the 2nd edition of the Environmental Monitoring handbook, and there are some specific chapters I'd like to call out. I urge you guys to take out your phone, scan the QR code. It is available for download, so it's ready to go. Some of the content that I'd urge you to kind of take a look at is the chapter on root cause analysis, another whole chapter on data management and utilization, and one of my favorite chapters, it was written by Anna Lozano, is the one on environmental sampling and how it can be used to validate non-process preventative controls and prerequisite programs. And if we still have some available at the booth, you're welcome to stop by. We may have some hard copies, and Anna might even sign one for you.
No. Stop. I want.
And I'd just like to highlight some additional resources that we use to build this today. So with that, any questions for us?
Yes.
Any questions for Anna and Arlene? There's got to be one. Excellent, eh? We're going to get the microphone there for you. Unless you want to bellow it out. Sorry, he'll give you the microphone.
Obviously, with Listeria, you don't want to bring it into the facility and test in-house. Are there third parties that offer this service or that you guys collaborate with?
Can you repeat the question so everyone can hear? Sorry.
Sure. Index quantification, right? That's something that you guys mentioned in your presentation. Just wondering if you guys partner with a third-party lab or someone that you guys work with to do that instead of just, because not a lot of food facilities want to do Listeria pathogen testing in-house, right?
Yeah, that's totally understandable.
Yeah, so I'll take, I think we have two pieces on this answer. Like the first one is that we're not bringing anything and we're not growing anything that we don't have in our plant. So that's the first part, right? So if we are collecting samples, environmental testing samples, swabs, sponges in our surfaces, and we are testing for index, we don't need to enrich. If you are testing for pathogen itself, if you are enriching, that is a different story. That is the presence, absence, the type of molecular detection systems that we have in the market, or traditional methods that you can send to a third party. If you don't want to bring that type of testing in-house, you can still do some index without the need of enrichment, because you will quantify. There is a recovery kind of piece of on the process, but you are just like doing total plate count or coliforms in your surfaces. You're just counting what you have in your plant. That is not an official pathogen test, it's an index test, and you are not enriching. So there's no hazard there, let's say, if you're already doing indicator testing in-house, of course. And for the third-party lab, I'll let you take that one.
There's actually somebody here in the room that can probably answer this better than me. Kim Hopkins, do you know about Listeria species plate, and is it being used routinely?
I don't know if he's here.
So I know, thank you. So there is a Health Canada enumeration method, which is a plating method. It's a spread plate method. Primarily it's used on food samples versus swabs, but potentially it could be used for swabs. It would be a species test that would then, if you had suspect colonies, would be confirmed to whatever species was there. But I also know 3M or Neogen has the Listeria plate as well, so that's something we don't offer in our labs at the moment. So, yeah.
Thank you.
Thank you. Oh, question there at the end. Oh, sorry, they're coming with a microphone.
Hello, thank you for your talk. Really great. Didn't know there was a compendia, so that's fantastic. Salima from ProSource Scientific. I have a question. We talked about statistics a little bit from other talks. Often when we're sampling, it's recommended, for example, a 10 by 10. And you mentioned mapping. Can you comment on the statistical relevance of depending on, a sponge swab or a 10 by 10 area, the relevance of are we truly capturing what is going on if we are relying on that? And have you looked into that at all?
Yeah. You want me to take it?
Sure.
Yeah. Okay. So, sorry, what's your name? Salima. Thank you for your question. That is a great question because, yes, you have to adapt the sampling device to the surface that you are sampling. It doesn't make sense to, for example, sample a roller of a conveyor with a sponge and sampling a floor or a wall or a flat, big surface like a conveyor just with a swab for this type of testing. So that's the first piece. You have to accommodate. There are different sizes in terms of sampling devices, so swabs and the sponges and a sponge stick. There's some even sponges that come not with a stick, but you can use your hand. This is the best tool we have to get to those sites. That's one. Second, in terms of the size, yes. So the swabs, we usually recommend a 10 by 10. That's what the theory says, and centimeters, and then sponge 30 by 30. Reality is that in our plants, we have a variety of sizes and forms in our surfaces. And because it's unique, your process is unique to you, you have to fit that to your needs. So if it is an outlet, for example, and then the swab gets in, but you cannot do like a 10 by 10. It is important that, statistically speaking, you are consistent on the way that you sample and that you document how you do that and train your team on how to do that. If you're going 10 times in and right and 10 times out and left, so everyone can do the same, so you can compare the data, and the data that you have can actually be used. Because if I am doing like this, and then Arlene is doing things like it should be done, stick to the process that she usually do. So our results will not compare. So the consistency will be the other one, and the third one that I would take is the neutralization power of the broth that you're using for testing, depending on the surface. On the zones 1 and 2, usually we rinse really well, because otherwise the sanitizer remaining there would be a chemical hazard for our food. So you don't need as much neutralization power from the broth that you are using to sample, like in other surfaces where you can have accumulation of sanitizer. So there you should use a stronger neutralizer so you can actually collect and not kill what you are collecting. So it's a grip. There's not one size fit everything. It's a collection of good practices that you can apply in your plant. I hope I respond to your question.
I do have one more point to add.
Go ahead.
I do training so many times with different facilities. It is so important when you're talking about a specific site that even if you have a picture, because we know that like different people might swab on different days and things like that. If you're talking about a flat surface, like a table or something like that, be very specific. Are you looking at like a rail adjacent to that table, or the crevice, or the actual flat surface? That might even be 3 separate sampling points for that specific piece of equipment. So it just has to be clearly communicated to everyone that's swabbing.
Thank you. Thank you. Thank you, ladies.
Thank you.
Good work.
We'll take everything. Okay. That's yours.